Hello and welcome to today's webinar on unlocking real-time insights with Microsoft Fabric. My name is Ben Jarvis and I'm Chief Technology Officer at Adatis, and I'm joined by Karina, who's one of our senior consultants, and Dan, who's another one of our senior consultants. So in terms of the agenda for today's session, we'll do a quick recap around what Microsoft Fabric is and how it fits into the data platform landscape. We'll then do a quick roundup of some of the key announcements from Microsoft Build, which was held a couple of weeks ago. We'll then talk in a bit more detail about one of the key announcements from Microsoft Build, which is the real-time intelligence feature in Microsoft Fabric. I'll then hand over to Karina to talk through some use cases for real-time analytics across a couple of different industries. And then we'll dive into a demo, and finally we'll wrap up with some next steps and have some time at the end for some Q&A if there's any questions that anybody would like to ask. As we're going through, feel free to add your questions to the chat and we'll be able to pick those up at the end. So to start, I'll do a quick recap of what Microsoft Fabric is. So when we're building out a data platform and building out any kind of data and AI solution, there's lots of different components that go into building that. And technology is really the smallest and probably the simplest part to implement. So we need to make sure that we've got a scalable and secure platform where we can start to ingest data, do some transformation on it, and deliver that curated data to the business so they can start to deliver value from it. But on top of that, we need to make sure that we've got the right enablement in place. So making sure that we've got things like a business glossary so people understand what data is in the platform, and making sure that people actually have the tools to start exploiting and using that data to make decisions. And then we need to make sure that we've got the right guardianship in place. So making sure we've got the right governance and security in place to ensure that we know what data is being used where, and ensure that we know how that data should be classified, so we can make sure that sensitive data is being secured appropriately and data is being used in an ethical and compliant way. And then finally, it's really the most important part, which is the people side of it. So we need to make sure that we've got executive sponsorship for actually ensuring that to kind of champion actually using data across the organization and becoming a data-driven organization. And we need to make sure that we've got the right training in place to bring people along that journey so they know how to use all of the cool new tools that we're giving them, but also know how to use them in the right way and know how to get some value from that data that we're delivering within the platform. So it's not just a technology problem. There's lots of different things that go into it and lots of different things that help us along that journey to becoming data-driven. So the way that we actually build data platforms has changed over the past few years to help with some of those problems. So initially we started with your typical on-prem data warehouse, where you take some structured data, do some transformation on it, and then load that into a relational data warehouse where it's then used for reporting and analytics. But then people like data scientists came along and they wanted access to data to begin building out things like machine learning models and doing some more advanced analytics on top of that data. And to do that, they needed access to structured data, but also semi-structured and unstructured data. So they might be using things like documents from across the business to try and gain some insight, or they might be using less structured data like JSON files or XML files and wanting to gain insight from those. And in order to enable this, we created the concept of a data lake, which basically gives us a central place to store that data and make use of it for analytics and data science. And the problem we had here is that our data engineers were still using that standard ETL process and loading their data into a relational data warehouse, but instead using the data lake as the source for that data. But then we had our data scientists who were working directly on top of the data lake and using that source data in its rawest format so they could start to build out their machine learning models. And that essentially created a problem because we didn't have a single source of truth. We had two streams of data. We've got one in our warehouse and one in our data lake, and people would come up with different results and wouldn't be using that data in the correct way. So then a company called Databricks came along with the solution, which is what they call the data lakehouse. And with this approach, we still have our centralized data lake where we can store data of various different types. But by using open and accessible file formats, such as the Delta format, our data engineers can start to build their curated assets directly in the data lake, so it's no longer in a relational database. And then our data scientists and other users can make use of those assets using whichever toolset they're most comfortable with. So for data scientists, that might be tools like Python or R, and for your sort of analysts, that might be SQL. You can still use all of those tools, but sourcing that data from the data lake. And because we're using those open file formats, we can quite easily switch out our compute layer and start to use the right tool for the job, rather than being constrained to a particular tool set. So that helps with some of those issues that I mentioned previously around giving people the right tools to start exploiting data, but also having a simplified way to start to apply some governance to that data and understand where it's actually being used. But when we're actually building out one of these platforms, there's lots of different components that go into it. So we need a way to ingest data, we need a way to cleanse data and validate that it's correct. We need a way to transform that data into its curated state. And then we need a way to store it within a data lake and apply the governance on top of it, as well as being able to serve that data up to users and allow them to actually consume it. So there's lots of different things that we need to consider when we're building that platform, and lots of different components that we need to make sure we've built and provided to be able to actually get the full value out of that platform. And when we're building these platforms in the cloud, you can kind of think about it as if it's building Lego. So your cloud platform is your Lego base, and then our cloud services are our Lego pieces. And each service has a different way of slotting together with others. And each service has different attributes and different ways of connecting to it, and different considerations that we need to have when we're actually making use of it. So there's lots of different things that go into building a cloud data platform. There's networking. We need to make sure that all of our services can talk to each other. We need to make sure that all of our services are secured appropriately, and we've got the right guardrails in place to secure them. And we need to actually write all of that code to kind of glue them together and pull them together into a nice data platform. And essentially where we want to end up is having a nice lakehouse architecture that's scalable and future-proofed and meets our needs that we've got for utilizing data both now and in the future. So obviously that's been quite a sort of pain point previously when we're implementing data platforms, and it's kind of one of the blockers for a lot of organizations in building a platform, is that they need to go through that process to stand up the platform and get to that point where they've got something that's ready to use. And that's where Microsoft saw a problem, and that's where Fabric comes in. So the idea of Fabric is to create a data platform as a service. So essentially what Microsoft have done is taken all of the services that you generally have involved in building a data platform and combine them all into a single software as a service platform. So within that platform, we've got a centralized data lake, which is called OneLake. And on top of that, we've got a unified governance layer, which uses tools such as Purview, but also a tool set called OneSecurity to basically allow us to catalog and understand what data is in that data lake and understand where that data is being used and make sure it's secured appropriately. And then on top of that, we've got various different compute tools that we can use to start to analyze and query and transform that data. So within that toolbox, we've got tools such as Power BI, which is for data visualization. So many of you will be familiar with Power BI, and it allows you to build out interactive reports and dashboards. We've also got Data Factory, which is our data integration tool. So that's allowing us to bring in source data and land that data into the data lake. We've got a tool called Data Activator, which it allows us to build real-time alerts on top of our data sets and gives us a nice UI sort of low-code environment to start building out alerts and triggering actions as data changes. We've got our data engineering toolset, which includes tools such as Spark, which allows us to use languages such as Python, R, and SQL to transform and query our data. We've got a full suite of data science tools, which allow us to create data science machine learning models and version those models and build out experiments and understand what makes up a model, and also allow us to productionize and publish those models. And then we've got our data warehouse tooling, which is your sort of typical SQL relational data warehouse, but based on top of data that's stored in a data lake. And then finally, you've got the real-time analytics stack, which allows us to ingest data in real time, transform, and then gain some insight from that data in real time. So essentially, we've got one platform that has all of those tools built into it. And that means that we don't have to worry about how those tools talk to each other. And we don't need to worry about any of that infrastructure. Everything is built in from the ground up and is ready for us to start using. So Fabric helps us to with the technical components of some of those areas of consideration that I mentioned earlier. So it's given us that scalable and secure software as a service platform, which means that we can deliver value to the business really quickly without having to worry about the platform side of it, and means that we can start to use the right tool at the right time. So we don't need to worry about hopping between different tool sets. We've got everything under one roof and everything is ready for us to start using. But it helps with some of those other softer areas that I mentioned. So from the enablement side, it gives us tools for both citizen and professional developers with the right guardrails in place to enable them to self-serve on top of the data and enable them to mark data as endorsed when it's reached a certain level of quality. From a governance point of view, we've got centralized governance through the use of Purview and through the One Lake platform. And we've got a single security model with a lot of the data loss prevention features that are built into Office 365. So we've got a really strong way to start governing our data and understanding where that data is being used. From the people side, we've got a single environment for collaboration, and we've got familiar tooling that is very similar to what most people have seen in the wider Microsoft ecosystem in tools like Office 365. And because we're not having to do all of that platform work to get the platform stood up and get it in a state where it's usable, we can have a really fast feedback loop and we can start to deliver some value really quickly to the business, rather than before where we'd spend a couple of months getting the platform stood up. Now we can start to get data ingested really quickly, get it transformed and start showing the business results really quickly. And that helps with that exec buying because they're actually seeing a return on investment really quickly, rather than having to wait for us to go through that process of standing up a platform. So that's it for the introduction to Fabric. So now I'll move on to some of the key announcements from Microsoft Build. So the link to the Fabric announcements is on the slide, and it's a really long web page with all of the various announcements that were made at Build. And if you're reading it from sort of yourself, it's probably going to take at least a couple of hours to go through and digest. But I've tried to summarize some of the key announcements on this slide. So the main announcement was the real-time intelligence platform, which I'll go into a bit more detail on in a second. But there's various other areas that Microsoft have been invested in and have released features around it at Build. So I'll just pick out a couple of key ones. So one is Fabric data sharing. And essentially that allows you to share data from within your One Lake platform with other third-party organizations. So that's something that we see a lot of within areas such as the NHS, where they're wanting to share data with other trusts or other external parties. With Fabric data sharing, that gives you a really simple way to do that in a secure way. We've got the GraphQL API, and that basically allows us to integrate data from within Fabric with our applications. So that means that we can we've got a nice clean API that we can use to query data from Fabric from within, say, a web application and start surfacing that data up to our users. We've got some integration with other third-party tools, so really close integration with tools such as Snowflake and Databricks. So that makes it easy to take data from those tools and bring it into Fabric. So that really simplifies that process and means that you don't have to have a platform that's built just in Fabric. You can start to bring that data from other providers into the Fabric ecosystem quite easily and start surfacing it up to users. And then finally, one of the really key announcements was the native Spark execution engine, which was announced at Build as well. And basically that's a really highly optimized way of transforming data. So Microsoft have rewritten the Spark execution engine in C++, and that gives a really good performance when you're transforming data using tools like Spark, and means that we can increase the performance of some of those workloads that are running in Spark without making any code changes. We can just switch over to that execution engine and start to get some of those benefits straight away. So that's another really useful feature. So now I'll go into a bit more detail on the real-time intelligence features. So the real-time intelligence platform was really the key announcement around Fabric at build. So essentially what Microsoft have tried to do is to build out an end-to-end offering within the SaaS platform that Fabric has, that allows us to ingest events from various sources, whether they're things like IoT devices or transactional systems that are publishing events, and allows us to basically store that data within the Fabric platform and then start to build out transformations on top of that and build out things like AI models on top of that data, so we can then start to gain some insight from it. Whether that's through surfacing dashboards to our users so they can look at that data in real time and start to make their own decisions, or by building automated processes that will look at changes in that data and start to take some kind of action or trigger some kind of process when that data changes. So essentially what Microsoft have tried to do is pull all the tools that you generally use to build out that kind of architecture into the Fabric platform under the banner of real-time intelligence, so we can really easily start to ingest that data in real time and start to take some action and make some decisions from it. And some of the key features that we've got are simplified stream ingestion. So out of the box, we've got support for various sources, and it's really easy to get that streaming data into the platform. We've got the ability to do that in a low or no code experience, so we don't need to write code to do that. It's kind of a click and a drag and drop interface that allows us to get that data into the platform, do some basic transformation on it, and then start to show some results from it. But as well as that, we've also got a really good professional developer experience. So the real-time intelligence is built on top of the Custo engine, which is used across a variety of Microsoft services. And that basically gives us a language called KQL, which allows us to start writing queries on top of that streaming data, and gives us a really powerful way to start to do some analytics on top of that data and gain some insight from it. And then finally, it's obviously all based on a SaaS environment. So previously we'd have to do quite a lot of work to string together services like event hubs and stream analytics, and maybe tools such as Databricks to start doing that streaming analysis. But now we've got that single SaaS environment, and we've got all of those tools that we generally want to use under one roof. And that means that we can get that data in and start to deliver some insight from it really quickly. So we don't have to go through that process of stringing lots of services together to deliver an end result. One of the key features of real-time intelligence is the real-time hub. And basically that is the area where we can start to ingest all of our data from various sources. So we've got out-of-the-box support for tools such as event hubs, so we can get events from those event hubs into Fabric really quickly. But we've also got tools for other cloud providers, so things like Amazon. We've got support for their Kinesis streams, so we can get those into Fabric really easily. But also the wider Microsoft ecosystem, so you can stream data from things like IoT Hub, but also the Fabric platform itself and other tools such as Cosmos DB and Azure SQL. So it basically gives us that really simplified way to get data ingested into Fabric, and gives us a really nice sort of centralized place where we can see all of our real-time streaming data and start to make use of that data for either processing where we want to transform it in some way, analysis where we want to visualize it, or some kind of action where we want to actually take an action on top of that data when it's hit a certain threshold. In terms of how this looks in practice, this diagram shows the way a streaming architecture would look. So on the left-hand side, we've got our data sources. So they might be things like a Kinesis stream or an event hub, or something like Kafka. And then we basically push that data onto an event stream in Fabric. And that's basically our sort of ingestion point where we can get data in and then we can decide what to do with that data. And from that event stream, we can either push data into an event house, which is basically a KQL database. So that's a place that we can start to query that data and start to transform it. And then from that, we can start to push that data either out to Power BI for visualization, out to some of the real-time dashboards for more real-time type visualizations, or into our reflexes where we can start to take some action on that data. And all of that data is stored within one lake. So that means that it's really easy for us to stream the data in and start to transform it in real time and get those real-time insights from it. But we can also push the data into one lake, and that means that we've got easy access to it for more batch type processes. So we can still use the likes of Spark to query that data and use tools like SQL to query that data in more of a batch orientated way. But we've also got that really powerful ability to query the data from KQL if we're looking at it in real time. So that's all I had for my section. So I'll pass over to Karina now to talk through some of the potential use cases for real-time data.
Thanks, Ben. Yeah, so as following on from as Ben was saying, Microsoft have released the Real-Time Intelligent Hub, which is, as they're saying, a single location for all data in motion, where they've said that users can discover, manage, and leverage all their streaming data and sources and more. So we're going to take a look and discuss a few different businesses and companies and how they can use this to make a difference for them. So we're going to start off with the higher education industry and focus on a couple of these individually and to go into a bit more detail and how they can leverage their real-time data to make data-driven decisions. So you've obviously got like student engagement and retention. So you can have real-time attendance monitoring, live participation tracking. So if everybody's in a room, we can set up some real-time data analytics for you, where if everyone's struggling on the same area or same particular topic, they can highlight that and they can say that they'd like to go over that in real time, and then the professor or the instructor can see that and be able to reevaluate their lesson plan to be able to go over the bit that everybody seems to be struggling with. You've got like campus security and safety, you've got emergency notifications, health monitoring. We've got research and innovation, where you've got live data streams for research. You've got collaboration tools, enabling real-time collaboration and data sharing among research teams, fostering innovation and speeding up the research process. It's really going to make a difference to how people learn and how they can all come together from all over the world in a real-time time frame. And then we've got some other areas of like location management, cost saving. Are you using all the space and the rooms and the Wi-Fi connections? We actually did this here at Adatus for our higher education client, and was able to provide real-time data on the rooms and space which weren't being utilized, and was able to add value to where they could save time and allocate rooms based on the size of the classes and how they were being used at the time. So this is just to give you a couple of ideas on the higher education section. If we move on to the next place, if we look at like the legal sector, there are other ways that real-time data can assist with them. You can improve monitoring and proactive management of cases, optimize billing processes and financial management, responding to feedback in real time and keeping clients informed and up to date, streamline processes and utilization. If you use real time to track client interactions and feedback, you can analyze the data and identify areas where the client services can be improved. If clients are frequently inquiring about their case studies and like the administrators are being overwhelmed with the amount of calls being coming without much of an update or being able to tell them very much detail, you can give them real-time case statuses updates where they can just see exactly what's moved, what's required, what's needed, what they can do to move it forward, and how they can implement automated updates. So you've got Dynamic task allocation. Workloads can be managed more effectively by allocating tasks dynamically based on real-time data about current workloads and deadlines. You've got your client relationship management. You've got your immediate client notifications. You've got live chat and instant support. Offering real-time chat support on their platforms allows clients to get immediate answers to their questions, improving their experience and engagement. You've got, and then if you go into like the legal research and compliance and risk management, you've got up-to-date legal research, access to real-time legal databases and news, ensuring that everybody's kept up to date and that the references are of the most current laws, regulations and case precedents, which is obviously really crucial. And then you've got like compliance monitoring, so real-time monitoring of regulatory, speak to my words today, sorry, changes in compliance, helps everyone stay compliant with the latest laws and regulations, reducing the risk of legal penalties. All of this in real time. Your financial management, live billing and invoicing, being able to real-time tracking of billable hours and expenses. You can get your invoices out in real time. The clients can see exactly in real time what's been worked on, what hasn't been worked on, and they're able to pay them and receive them immediately. You've got when you talk about risk management, you've got your crisis management in situations requiring immediate action, such as urgent client issues. Real-time data enables responses to be quick and effective. Your real-time risk assessments, by continuously monitoring case data, performance, external factors, changes in law or market conditions, allow for the information to be available immediately and mitigate your risks as quickly as possible. So if we move on to telemetry and IoT data, on the next slide, there's some over around here. So, you've got real-time compliance monitoring. So you've got IoT devices can monitor manufacturing processes and conditions to ensure compliance with industry regulations. Real-time data can alert teams about potential compliance breaches, allowing for immediate corrective actions, which also ties into performance monitoring. It can give you telemetry, real-time data from manufacturing equipment. It can verify compliance, contract terms, production rates, quality standards. You can get equipment health monitoring from the same way. Continuously monitor the condition of machinery and equipment, and it can help predict potential failures before they even occur, being proactive instead of reactive, allowing timely maintenance and reducing downtime. Microsoft have actually got an incredible user case available to do with some motorsporting, and how they use this data to be able to predict and analyze and come up with real-time problems with the cars themselves, opposed to previously, before enabling this, it took over 30 minutes for them to be able to be aware that there was a problem with the car or on the sport or something with the engine. They're now down to I think a minute. It's incredible, and their user case is fantastic that they've been able to put together from that. You've got your vibration and temperature analysis. By analyzing data from vibration and temperature sensors, manufacturers can identify abnormal patterns that indicate equipment wear or impending failures. Using this coupled with real-time data, you can have immediate updates on the information and be able to react. If we take a look at your customer experience, you've got your customer products. Real-time data from IoT devices can enable the production of customized products to meet specific customer requirements, enhancing customer satisfaction. You can even take it to the next level and have after-sales service. Enable products can provide real-time data on their condition and performance, allowing manufacturers to offer proactive after-sales service and support. All giving you data-driven decision-making. You can have operational analytics, real-time, can provide insights into performance, helping management make informed decisions to improve efficiency and productivity. You can have your forecasting and planning. It can enhance forecasting accuracy for production planning, inventory management, and the demand prediction, leading to better resource allocation and reduced costs. So Microsoft have actually worked with the NHS and the University of Aberdeen to build this brand new solution called MIA, which I think is on the next slide. So the way they've got it to work is it's working with AI and real-time intelligence. And so what they've done is they've built this piece of software, and it's all about working with mammograms and the detection of breast cancer. So the current process that happens is one doctor will have a look at the scan and look for any anomalies, apologies, and then a second doctor will do the same, and then they come together and they both report their findings, and if they agree somebody needs to be called back, they call back, and obviously if they don't, they don't. So obviously the human eye can only detect so much, so they've built this extra program called Mia in the background that will go away and will scan read that scan, and they've used real-time and machine learning to figure anything that doesn't look right, that the human eye wouldn't detect. So this particular scan you can see on the screen right now has got two, which are circled because I don't think anyone would notice these, and the doctors didn't notice it either. And they've picked these two areas which have got callback machine learning behind the sign that said we need to call back this person for another scan. So the real-time data has sent that off, it's contacted the person, and it's asked them to come back in to have this reevaluated. And what they've said is that it is estimated that if it was rolled out for the whole of the NHS, 12% more breast cancers will be detected early, and therefore even higher survival rate, and that 30% of workload saving will be made. This particular case from this scan was actually a breast cancer diagnosis that they would not have been able to detect for at least another 6 months, if not longer. And I think the mammograms are done every 3 years, so it could potentially have even been 3 years before it was detected. Because it was detected so early, it was absolutely survival rate 100% and all dealt with. So these are edge cases, these user cases, and this potential that we have with this real-time data can make a difference just in all of these different industries, in everybody's lives, and it's just gonna cost save. It's going to give us the opportunity to have data earlier and more accurate than we've ever had before. So I think that's it from me, and I'm going to pass you on to Dan, who's got a demo to go through a real-time situation that we put together.
Thanks, Karina. Let me share my screen. Cool. Hopefully everyone can see my screen just fine. So just before I get into the actual demo, what I wanted to demo today was just some of the sort of capabilities and features within Fabric to allow you to create a real-time solution, basically. So these decisions can be made in sort of seconds and minutes rather than hours and days. The particular kind of use case that we'll be going through is a sort of one around the construction industry. But the sort of architecture that we'll be following, the features that we'll be using could definitely be applicable to sort of any industry, whether it be like retail or healthcare, etc. It's just this particular use case is one for construction industry. So what we've got in this example is we've got sort of 3 different data sources. We've got some sort of telemetry data from cranes and from diggers, and also some weather data. And so that might help to answer the sort of questions such as, what are the utilization rates for cranes and diggers? Are they getting utilized as much as they should be? Maybe there's some questions around compliance as well in terms of CO2 emissions. Is that in line with kind of what you'd expect and meeting sort of regulations that you might have to meet? And things like maybe engine running time, does that impact when they should be doing maintenance on their diggers, etc. So these are all the sort of questions that we're trying to answer. So where does that all start? The first kind of part of that we can do in Microsoft Fabric is this here, which is the event stream. So an event stream is a no-code way really of kind of bringing in your real-time data from a particular source, and then you can do a little bit of transformation to it and then pushing it to a destination. So you can see here on our left, this is kind of our source. And effectively what you can do here is you can create an event hub. It'll create a kind of behind the scenes for you, and as long as you've got some sort of source that can push to an event hub, then that means you can sort of bring in that data in real time and take advantage of all the benefits of an event hub in terms of extremely low latency and being able to sort of ingest millions of data points. You then get this sort of small event processing window, which is quite useful for just a small bit of monitoring and insights, being able to see that the data is going through, last event time, last refresh time, etc. You could also do some transformation here. You can, the typical ones that you'd expect in terms of group bys and joins, aggregations, all that sort of thing. And then you can push it out to your destination, which is a KQL database, which I'll come on to in a minute. One thing that's worth noting here is that we're not doing the transformations here because we're treating this a bit like how we treat sort of an overnight job, really, in terms of we're almost just sort of staging the data here. We're bringing it in from the source, and then we're staging it, not really doing anything to it, because we'll do the transformations in KQL where the performance is a little bit better. The other thing that you might notice here is you can see the way it says streaming. Now this could be slightly misleading, so I just wanted to clarify it a little bit. The streaming doesn't necessarily mean that the data is quite literally streaming through now, although in this instance it is. The streaming is more of an indication that it's a sort of successfully connected in terms of, if you imagine testing out a connection string, it says, connection is successful. It's more akin to that, really. This sort of means if you want to ingest more data, you don't need to do any changes. It's kind of set up correctly and working. So as I said, it's pushing to a KQL database as our destination. So I'll just go to that now and show you a bit about that and what it looks like. So you can see here we've got this cranes table. You see we've got sort of a couple of other tables for other data sources which are working in basically exactly the same way as I showed you there in that event stream. Like I say, this is our kind of really staging table. No transformations really been done, and it's fairly kind of standard at this particular point. You've got some sort of functionality here in the UI to be able to, again, similar if you wish to maybe Management Studio, select top 1,000 rows. You've got similar here where you can show the data and it can kind of write some KQL for you. Again, similar to sort of a SQL experience where you can just have a quick browse at the data kind of through the UI without having to write any code, really. The other thing that's maybe noteworthy here is this bit here, which is one lake availability. So we've got it as inactive, but what you can do is you could activate this, and what this will do, as kind of Ben alluded to earlier, is this will then write this table down into the one lake in Delta format, and then you can take advantage of it in some of your other engines within Fabric, such as Spark. So this is obviously really useful in kind of the use case or an architecture whereby you want a section, kind of a Lambda architecture, whereby you've got this section for real time, but then you still also have got your batch processing. It means that you can have it kind of in Delta and therefore interact with it not only with your real time part of your architecture, but also with your kind of batch processing part of your architecture. So from there, we obviously need somewhere to kind of transform the data and to write any business logic or do anything like that. That's where KQL comes in, and these particular functions, you can see we've created one here, and there's just some sort of very basic transformation. It's looking at that stage table, doing, like I say, very basic logic, and obviously this is where your business logic can get as kind of complicated as you want, because this will then form our source for our semantic model in Power BI to actually then kind of do some of the reporting on it. And again, we've chosen to do the transformation here because we could have done it in event streams, or we could do some of it in the semantic model, but the performance in KQL is extremely impressive, and so that's why we've chosen to do it here. And so this is sort of akin to maybe your gold layer in a kind of normal architecture, in a medallion architecture, whereby this holds your business logic, and your transformation to get it into a state whereby you can actually report on it, and it becomes a lot more useful for end users. So this effectively is a function, but it's really acting like a view. So if I then go to our semantic model, you can see we've got this kind of an error saying table can't be shown because in import mode. That's not quite correct, because if you look over here, you can see that storage mode is actually direct query, which is exactly what we want for this real-time scenario, because obviously direct query effectively means that we're not importing the data is stored in the source, and we're effectively querying the source when we need it. So obviously for this real-time scenario, that massively helps with the performance and keeping it as close to real-time as possible, rather than having to trigger any sort of like import or refresh or anything like that. So that's kind of critical in this real-time architecture, that this is in direct query mode. And then you can see again, if you used to use in Power BI, not too different to how we'd have this again in sort of like a batch architecture, whereby we create some measures using DAX, bring in some other columns that we maybe don't need to transform or create measures off of, and things like that, really. Nothing too fancy. And then the final point is that we can then create a dashboard from this, or a report from this, similar to again how you're probably used to seeing, where you can obviously have the data, whatever data is in your data set, really. So here we've got things around utilization percentage, lost hours, how many days since the crane last got maintained, CO2 emissions, things like that. So again, you could probably take this report a bit further and link it into a reflex in Data Activator, which means you could basically set a particular alert on this, and then you could say, once perhaps CO2 gets over a certain amount, then trigger an email, trigger a Power Automate to do something, and trigger those further processes so that you can kind of keep an eye on these things as close to real time as possible and actually take an action on them as soon as possible as well. The other thing that's just worth a note here is that if I go to the sort of page settings, the other important bit, again, to kind of keep this as close to real time as possible is page refresh. You can see we've got it on every 10 seconds, and you can go as low as every 1 second. And again, this just helps us to keep it, like I said, as close to real time as possible so that there's no sort of manual refreshing of a page or waiting for something to import. It's refreshing every 10 seconds on an automatic page refresh. And so you're just really trying to shorten down that time from when you bring in the data to when you actually get it in your reports, and you can make decisions based on it. I think that's all I wanted to show really. So I'll hand back to Ben now to just go through some next steps.
Great, thanks, Dan. I will just sort out my screen sharing again. Great. So yeah, just in terms of next steps. So at Adatis, we're able to assist with all stages of the data maturity journey. So whether you're at the stage where you've got lots of data and you don't really know what to do with it, we can carry out some envisioning to understand what the potential use cases are and start to build out a roadmap of how you can actually adopt data. And then we can also do that delivery side of it, so actually building out the solution and giving you that platform to build on top of and start to build those use cases on. And then finally, we're able to help with that enablement side, so actually doing the softer side and making sure you've got the right processes set up and making sure that your team is trained to actually get some value from your data. So really, we're able to help with that end-to-end journey of helping to assist you in building that data culture and starting to use data within your organization. From the Fabric point of view, there's a couple of things that we've got on offer at the moment. So we're currently offering a free Fabric workshop, and that's basically a half-day workshop where we can come in and talk to you about your existing data platform or existing data architecture, understand some of the challenges that you've got, and then look at how Fabric could potentially fit in and where Fabric could potentially help you to solve some of those problems that you've got. And then off the back of that, we're also offering a 5-day proof of concept, which is where we can basically build an end-to-end solution using Microsoft Fabric and get some data ingested, do some transformation, and start to gain some insight from that data. And there's Microsoft funding that's available to help with financing that proof of concept as well. So it's something that we can get set up really quickly and deliver at a really low cost to kind of get you started on that Fabric journey and get you started on that route to using Fabric. So that's all we had for the session today. So we've got some time left now for Q&A. So if there's any questions, then feel free to add them to the chat. I see that we've got a couple in here already. So Cara, do you want to start running through some of the questions? Or I'll actually run through them. So I see that we've got one, which is, will the recording be shared? So yeah, I think this session's been recorded, so we'll get that sent out at the end of the session, and that will be uploaded to YouTube as well. So you'll be able to access the session after and recap on all the content we've covered. Just in terms of some of the other questions, so we've got, how does the real-time intelligence functionality in Fabric compare to Azure Data Explorer? So we've got quite a few customers who have obviously looked at tools like Azure Data Explorer, which was kind of the precursor to real-time analytics in Fabric. And that's something that is used quite widely and used across lots of different organizations for these real-time analytics type use cases. The main difference with Azure Data Explorer is that it's more of a PaaS service, so it's not on the kind of SaaS end of the spectrum. So it's an Azure service that you can provision in your Azure subscription. And the key difference really is that it has the same underlying platform as the real-time functionality in Fabric, but there's a bit more configuration required to actually get data into it. And you've got a bit more flexibility over some of the configuration around things like clusters and sizing those clusters. So we'd really only recommend it if you had a real kind of niche use case, or you had a use case that was ingesting lots of data, or had some really specific SLAs around how quickly that data needs to get through the platform, just because you've got a bit more flexibility around how it's configured, where the functionality within Fabric gives you a bit more of a kind of out-of-the-box solution that you can get to grips with really quickly and get some data ingested really quickly with. We also had one question around how we can integrate real-time and batch data together. So that was something that Dan touched on in his session around being able to sync the data from the KQL database down to OneLake. So basically that allows you to in real time sync the data that you're ingesting from the data streams down to OneLake. And then that will allow you to start to query that data from tools like Spark. So if you're looking to have more of a batch processing pipeline where you're running it, say, a couple of times a day, you could build that out using tools like Spark and Data Factory, and use the data that's stored in OneLake to perform those transformations and build out that data model. So it's really good that that data is synced down to OneLake and there's no interaction required from you. It just happens out of the box. So it makes those streams of data really easy to build. The other side that's worth mentioning is if you've got some batch data stored in the data lake that you want to use in the real-time functionality in Fabric, you're able to shortcut that data into your KQL database. So say you had some reference data about devices that you're pulling IoT data from, you could create a shortcut and pull that data into the real-time element of Fabric. And then that would allow you to combine that data with the data that you're streaming in. So it's easy to go both ways, both using the real-time data in a batch process, but using the batch data in a real-time process. So it's quite simple to set that up and easy to use those data sets. I think that's all of the questions that we had. So we'll probably wrap the session up there, but thanks to everybody for listening, and I hope the session was useful. We'll be following up after with obviously the recording and some other bits as well. So yeah, if you're interested in any of the offerings that we mentioned around that Fabric briefing or the Fabric POC, then feel free to reach out and we'll be able to help with those. But thank you for listening.